Alright guys, welcome back to my channel. This is going to be a video, it's going to be a video series for beginners. What beginners need to know about their airplanes before they take it out for their maiden flight. And it's always a nerve-wracking thing. Have you forgotten about anything? And I make some of these mistakes to this day, so it's a good thing to go over what are the 3 to 5 major steps that you do before you take your airplane to the flight line. So let's get started. Okay guys, let's get right into it. So the first step in getting your airplane ready for flight is to make sure that your control surfaces are moving in the correct direction. What I mean by control surfaces are the ailerons or the rudder or the elevator. Okay, so I'm going to start off on a simple wing to start with, and I'll also show you this on this Corsair over here, which has more traditional style of controls. So the biggest thing that I learned, and this is something I learned from flight test, is to hold your radio directly above your model. I have everything bound up already here. So what you want to do is take each control surface and point it towards the control surface that it's going to be controlling. What's going to happen is as I point this stick to the control surface that's supposed to be moving, that surface should move upwards. So if I'm going to move the stick to the right aileron should move up as it's doing here. Same thing with the left. I'm going to go left and that should move up. Now if I'm going to be going back for back elevator, these both should raise up. And conversely, if I'm going to go down, these should go down. So that is pretty simple for this type of a wing. Okay, so let me go ahead and bring in the Corsair. We'll go over that one more time. Okay guys, so this is my Corsair. It's more of a traditional style aircraft. Now I have my rudder set up on my FPV camera, so I use that for that. But I will kind of just demonstrate with my hand what we do with the rudder. Okay, so once again, you hold the radio on top of the airplane just like this, and if I put my aileron stick, this is right and left on this right stick for mode 2 is going to be aileron. So if I push my aileron stick to the right aileron should come up. Same thing with the left aileron should come up, which does. And with the elevator, let's see, can you guys see the elevator? Yes. If I point the elevator stick towards the elevator, that control surface is coming up. So up, up, and up. And of course, if you push this one away from you, it's going to go down. Now, as far as the rudder goes, same thing here. If I'm going to push the rudder stick to the right, the rudder is going to go to the right. If I push the rudder stick to the left, the rudder is going to go to the left. So that's the only thing that's a little bit different in with this technique. So that's number one. Once you get those type of things taken care of, you can worry about how much throw to put on there. You can go into expos and everything else, but that comes on a different video. Well, okay guys, so the next thing we're going to talk about now is CG, and CG stands for center of gravity, and every airplane has an ideal center of gravity. Now, most airplanes from the manufacturer will have a suggested center of gravity. It's usually so many millimeters behind the nose or from the rear forward. You want to go off of those to begin with, but you also want to do some research online, because a lot of times the CG or the center of gravity is not perfect from the factory, because these guys are engineers. They don't usually go out and fly them. Sometimes they're taking a guess and sometimes they get it wrong. So go on to RC groups, look up your airplane and say, hey, what do you guys suggest for CG? And some people will say, oh, it's 240 millimeters in the manual, but we have all found that 200 millimeters is better. So go with that. That's always the best way to go. So usually, once I find my CG on my airplane, which I have marked right back here, I put 2 little dabs of hot glue there so I can actually just put my fingers on there and just hold it up, and you'll see that the airplane balances fairly closely to that. And of course, most people are going to tell you that having a slightly nose-heavy CG is better than having a slightly tail-heavy CG. What that means is that if you hold it dead on the CG and the airplane just barely starts to tip to the nose, that's always more preferred than tipping towards the tail, because a tail-heavy airplane will sink down on the tail like this, and then all of a sudden your ailerons and your elevator will have less authority because there's less air going over them, because it's dipping towards the tail. Now if it dips towards the nose, it's much easier to fly. Okay, so this arrow here, I have my CG set right about here, and you can see it's just about perfect. Now, when you're testing CGs for different types of airplanes, it's different. A wing is going to be different than a low wing Corsair or Warbird, and the same thing is going to be different for a high wing glider. So let me just show you guys here on my Corsair here. Anytime you have a lower wing airplane like this, you're going to flip the airplane upside down, and you're going to put your fingers on the wings like this, and you'll find the balance point CG is basically a balance point. And if it says it's recommended, 50 millimeters behind the leading edge, then you put the mark there and you put your fingers there, and then you put your fingers on and it goes like this, it's extremely nose heavy. Now if you put your fingers here and it goes like this and it drops the tail, you know that it's extremely tail heavy. So you want to play with the position of your battery in your airplane, shifting it forward or backwards, or even adding weight to the nose to get your CG on. Lots of planes need weight in the nose, so don't feel bad about adding weight to an airplane if you need it. Alright, so let's check out a high wing glider real quick. Now when you do a high wing glider like this, now I don't have the battery in here, so it's going to look like it's kind of tail heavy, but you don't flip the airplane upside down. A high wing glider like this, you're going to have the CG, you're going to hold it right underneath the front of the wings like this, and when the battery is in with this one, it's about right here on the wing. So I don't have the CG mark. Actually, I do have the CG mark here. It's like a range between the first mark and the second mark, so I usually put my fingers right between there. So this is the way you're going to be testing your CG. Now if you want to go more technical about it, you can get a 2x4 and drill 2 holes in it that's big enough for a number 2 pencil to go into, and have the erasers facing up so you can actually get very accurate on your center of gravity. So anyway, that's an easy way to get to it. Like I said, getting a slight bit nose heavy is always more preferable than slightly tail heavy, so make sure you guys remember that. Okay guys, the thing is prop direction. Which way do you put the prop on? Do you put it on this way, or do you put it on this way? And if the motor's going around the correct direction, basically you're going to get thrust going back here, so you'll have wind coming back. There is an incorrect way of actually putting on this prop, because if you just take this prop and flip it upside down, it doesn't change the direction of the pull or the thrust of the propeller. It just becomes more or less efficient. In most cases, there's going to be writing on the propeller. This one happens to not have any writing. So how do I know what is the front and the back of this propeller here? Well, I've actually put some tape here on the back of the propeller to weight this propeller right. If you take a look at the profile of the prop here, you'll see that the top portion of it here has a bit of a curve to it here, and this has a bit of an undercurve to it. So it's a bit like an airplane wing, how the top of it's going to be more curved than the bottom of the wing. So that way I know that this is the top surface. It's going to be facing the front of the airplane. Normally, like I said, there's going to be some writing on this prop telling you the size and the pitch of the prop. That always faces towards the front of your airplane. So if I were to put this prop on this airplane, it would go like this and not like this. You can see that the cut is still in the same direction, but having that airfoil going the proper direction is really, really important. So numbers and letters always going towards the front, whether it's a tractor prop, which this means it's pulling the airplane forward like a tractor, or if it's a pusher prop. So even though, let's say this is the same way I would have this prop on this airplane, it's the same exact way that it would be here. You don't turn the prop around or anything like that. It's still letters and numbers of the prop still go forward. Let's see if we can see the numbers on the edge of this. You can see that the numbers here and the letters are facing towards the front of the airplane. So it's right here, and here's the front of the airplane. Okay. All right. So make sure you get your props on the proper direction going forward, and also that the motor's turning around in the proper direction as well. If you've got like a ARF or some type of ready to fly airplane, most likely that's already set up for you. Well, all right, guys, that brings us to battery selection. What battery do you use in your airplane? And if you've bought an ARF, which is an all-ready to fly type of airplane, most likely you'll have a battery, but if you have to buy your own batteries, make sure you take the recommended battery size from your manufacturer. But when I change the battery, it's going to you have to make sure that you adjust your center of gravity accordingly. So if this is a heavier battery, it's going to make this airplane more nose heavy, because this battery goes right up here in the nose of this airplane. So if it's a heavier battery, I'm probably going to scoot it back a little bit, and I'm going to test my CG again. Always check your CG when you're changing anything different from the manufacturer's suggestions. Alright guys, this is the last topic we're going to talk about, and that's, how do you know when to land your airplane? How do you know when your battery's getting too low? And how do you know when your plane's just going to drop out of the sky? So if you're new to LiPo batteries, the highest voltage on these batteries is going to be 4.20 volts. And what you can do is use a little battery tester like this, a battery beeper, which will go off when your voltage is too low, and you can set these to a certain voltage level. So let me just go ahead and plug this in. Now normally this has a beeper that I actually have disconnected this one because I don't want it beeping inside my office. This is the one I keep in my office. But you can see that this battery right now has is at storage charge, which is 3.8 volts, right around there. And it has a total of 11.4 volts. Now, like I said, when you have a fully charged battery, it's going to say 4.20 volts. And what you can do is change this. I'm going to show you here. You can push this little button here, and you can change the alarm on it. I'm going to push it here, and this won't beep. But this alarm, I'm going to set this as 3.5 volts. Now, when things get past 3.5 volts, performance goes really far down. So when it starts hitting 3.5 volts, this alarm will start beeping. It'll go beep, 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 really, really loud. So this is something you just plug into the balance port of your battery. So I've got my battery here. You just plug it in, just like this, into the 4 little holes that are right there. You plug it in, and once you set the your low voltage alarm, you can have it set at anything you want, between like 3 volts and up to like 3.8 volts, somewhere around there. It will go off at a specified time depending on what you set it to, so that we know when you're low on batteries and that when you need to land. Now, why is this important? Why can't you just run the battery out and then land it, right? Well, LiPo batteries are very sensitive to low voltage. Once it gets down to about 3.5, 3.3 volts, the performance goes down, 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 and it gets to 3.3 volts, and it goes woof, like this. So basically, and it's stressful for the batteries. It will start to create some different gases inside the battery that will start to make it puff. And that, once it starts puffing, the performance of your battery over time goes way, way down. So set your voltage alarm to somewhere around 3.5, 3.6 volts, and then be happy with it. And then as soon as it starts you hear that beeping noise, then you can land your craft. Okay guys, so I hope that helped you out, some of the beginners that are out there. I know a lot of you experienced guys already know these things, but it's a nice thing to go over. But if you guys have any questions about what I went over, or something wasn't clear because I was using verbiage that you're not familiar with, leave a comment in the description down below, or in the comment section down below. Make sure you like and subscribe my channel, and I'll talk to you guys later. See you on the flight line. Bye.